All right, well, good morning all to this Open-Autonomy presentation. So yes, I'm Martin Politick, and I work for Wenco Mining Systems. Again, we're a Vancouver, Canada-based technology company. Our core product is a fleet management system, so dispatching for haulers, but we do have a lot of different technology that we provide for open pit mining. So essentially, yes, I'm a software engineer by trade, and I've been developing control and positioning systems and monitoring systems for open pit mining for more than 25 years. And definitely, as I'm going through the slides and I'm talking, I'm told there's a little bubble at the bottom of your screen where you can go and type a question in the Q&A. Please do so as I'm going through the slides. I really like this to be interactive, and we can go a little bit deeper into what really interests you. So that I really like that type of interaction. I'm going to use definitely a lot of two acronyms, FMS a lot and AHS a lot. So FMS stands for Fleet Management System, and AHS stands for Autonomous Haulage System. I think there's a few other acronyms I might use. Unfortunately, it's in my blood. I don't even, see when I use them. And that's about it. Yeah, so let's make it interactive and let's go. Okay. So essentially, today, there's about 3 or 4% of haulage units, trucks that are automated in open pit mining. So essentially, you can see that in the next 10 years, there's going to be a big demand for brownfield operators to change their fleet to go from a manned fleet to an autonomous fleet. Then, if you're a brownfield operator, you've invested a lot of energy and a lot of time and money in your trucks, into your IT infrastructure, the radio infrastructure. So you already have all of that, and you'd like to leverage that. You would think that what you do is you take your trucks, you put sensors, actuators on top of them. You put a new computer with some software that becomes your software driver, and you're going to change your standard operating procedure to go from a manned operation to an autonomy operation. And that's how you think that you'd go to an autonomous haulage system. But the problem is that today the commercial products that are available, what you can buy is a complete full technology stack. You can't just replace one component, your driver. That's not possible. So the three commercial offerings, if you buy Caterpillar trucks and Caterpillar Autonomy, you're going to have to buy the Caterpillar truck, the Caterpillar driver, software driver, their AHS solution, and you will use only Caterpillar MineStar Command to be able to dispatch these trucks. So it's the only technology that is compatible with all these modules, and they can't interact with others. So, if you look at Komatsu, it's the same. You have a Komatsu fleet, and then you're going to buy Komatsu trucks with the Komatsu software driver, the AHS, and FrontRunner. You're going to have to run FrontRunner, and you will be using modular dispatch to do your dispatching. So same thing again. These modules are only compatible within each other, and they're not compatible with any other technology. The third one would be, the Hitachi solution. Same type of model. You buy Hitachi trucks. It comes with the Hitachi autonomy system, and you absolutely have to use the Wenco dispatching system. So this approach, the current commercial approach, has a few issues with it. So I think obviously one problem, what happens if you have a mixed fleet, which is pretty much common on brownfields. So worst case, what happens if you have 33% of Caterpillar trucks, 33% are Komatsu trucks, and 33% are Hitachi trucks? Do you need to run 3 fleet management systems? How do they work together? Further to that, is, again, if you're a a brownfield and you're sophisticated enough to go from a manned operation to an autonomous operation, you've most probably been running a fleet management system on your site. And what happens if the fleet management system that you've been running for 10 years is not the fleet management system that is compatible with your, the autonomous truck, which, is only a single flavor? Why is that a problem? Well, essentially, the fleet management system has, a good dozen of tie points into IT systems that, you're already running at your mine. So then to be able to take advantage of the autonomous trucks, you likely need to go and rip and replace this fleet management system that has been integrated over 10 years in your mine. So let's go through some of these integration points. So as the input, the fleet management system, will take the production plan for today for the shift. So what are we trying to achieve? How much ore are we trying to move? How much waste are we, trying to move to uncover ore for the next shift? What are the ore blend requirements from the mill? What's my block model? Where is my ore so I can achieve that plan? What's my roster today, and what are the certification for my operators for the different pieces of equipment that I have? Do I need to swap people around today because one operator hasn't been operating a particular piece of equipment and he might just lose his certification, and we don't want that. So that's another input. What's the maintenance schedule? Which machine are going into PM today, which are not going to be available throughout the day to achieve my production plan? There's also a tremendous amount of real-time connectivity between the machines, the heavy vehicles in the pit, and the fleet management system for health. All the exceptions that are happening on the vehicles are sent to the FMS in real time. And unfortunately, not like the vehicles that are on the road today, all these interfaces are specific to the model and OEM of that particular vehicle. So there isn't a standard. So all these interfaces are all specific to the particular piece of software, the particular piece of technology that you're using. So same thing with, again, the crusher and integration with the plant. So is the crusher up or down? What's the feed rate that we could dump into it? So those are all real-time integration points that are all separate, that are all non-standard, that feed into the fleet management system. And there's a bunch of outputs as well. So then, the fleet management system is going to tell the mill, here's what's on the belt, here's what's coming. So then, if the mill needs to change a few parameters depending on what's coming, then they can do it. Your whole, time utilization model is all, sent and done by the FMS. Your stockpile, so where your stockpile, how much tons do you have on that stockpile? What is the ore quality in all of these different stockpiles, and it's all done in real time. So then, you can feed maybe a loader at the RUM to be able to, have the proper mix for the mill. It feeds, again, all your financial system, your corporate reporting, and all these tremendous, like, dozens of ad hoc reporting that are, based and created and utilized on a daily basis on your mine, which are mapped to your particular FMS version that has a schema that is specific to that FMS. So again, unfortunately, there is no common schema or a normal schema that everybody uses. So if you replace your FMS, if you need to rip and replace this, you need to redo all of these tie points essentially to take advantage of an autonomous truck, which doesn't feel right. So essentially, I'm not going to read through this. You can read it, while I talk. But we've been talking to miners, and in the past, again, several years, we've had all these comments, and those are quotes from miners, big and small. And they're saying, well, it makes no sense that the color of truck I purchase dictates which technology I want to use or I'm able to use on my mine. That, you know, it doesn't make sense. You know, what has been happening, you know, in the past 30 years as far as technology, mines, and again, it makes sense, mines go and buy different technologies, assemble them, so they can, you know, end up with a best overall solution. You know, can you buy everything from a single OEM? Yes, but it's not necessarily the best adapted to your ore body, your mining technique, to, you know, the equipment that you have, to the people and the training that they have, and maybe sometimes it's even the support in the country you're in. Different products have different level of support depending on that country. So it really depends on, you know, your reality in the mine, which technology is the best and which technology component is the best. So having, you know, all your technology from a single vendor, maybe it's simpler for you to have, you know, a single throat to choke. So when something goes wrong, but essentially you're not necessarily having the best system that can serve you and where you can extract the most value out of your technology to have a lower cost of production, essentially. So those are the things that miners have, you know, definitely realized and have, you know, told us. So essentially back in 2018, okay, so, you know, this was going on and we had all that feedback and we said, okay, well, let's take a look at, you know, the current closed stack and where does it make sense where we can, you know, create interfaces there to start to break that up into smaller chunks that, you know, makes sense. So back in 2018, we started to think about, you know, I think the obvious places, which would be an interface between the fleet management system, which, you know, have been out there for, again, 30 years, are fairly well known what it does, and, you know, the autonomy system. So essentially, you know, the driver on the truck. So, you know, creating an interface there. So in 2018, we started ISO 23725, which essentially defines the technology, the connectivity, how to exchange messages between an AHS system and an FMS system. We also, you know, saw that, and especially BHP was a big proponent, and they pushed a lot for that, to create a drive-by-wire interface. So think about a drive-by-wire interface is a cab for a computer. So, you know, today we have pretty much standard cabs that have a steering wheel, pedals. You know, people know how to interact with those, and they're very standard. Well, we want to create a standard API for the computers. So regardless of the type of truck, whether it's fully mechanical, it's an electrical, it's a hybrid solution, or how, you know, the truck is controlled, that, you know, the AHS system that sits on top of the truck, so the software driver has, you know, interacts with the truck the same way it would with, you know, the different colors of truck that are available. So, you know, ISO 23725 is still ongoing. We have a draft version of it. So the standard is more than 100 pages. Unfortunately, it has not been published yet, so you cannot go and buy this standard. But pretty much everybody important in the industry, so different truck OEMs, the big truck OEMs are all there. Fleet management system people are also there. So there's participation from miners as well. So, you know, big miners all being represented there. But developing these standards, you know, these interfaces, really, we realize that, you know, we're not going to build just interfaces and blocks that build on top of each other, like, you know, we had in the other slide. So we're not going to be able just to pile blocks on top of each other. Open autonomy actually is that open ecosystem of services, meaning that, you know, it's going to be a one-to-many relationship between these services where they need to interact together really to provide an open autonomy. So what we've done through, you know, the design of 23725 is realize that there's really, at a minimum, these 6 components that a miner would like to go and be able to pick and choose the technology vendor that they want to use at their mine, which is again specific, that addresses a specific need for them. Let's go through them. So essentially, you have your base truck. So this is what you have today. You go and you buy your truck. You need to go and buy a drive-by-wire system that is specific for that base truck and that model and that vintage of truck. Hopefully in the future, this drive-by-wire kit you'll be able to get from the truck OEM directly. Today, that's not possible. So there are companies that create drive-by-wire kits that are adapted to particular base trucks. And they sell that, and then they define an API. So right now there's only specific APIs for specific drive-by-wire kits that are given to the autonomy systems. So that's the drive-by-wire. So right now we're missing this this layer that we know that we need for creating a specific API. So any software driver will be able to drive the truck. So obviously we need a block for autonomy. So that's the driver, the AHS part. We're going to need a map component. So actually, it's strange to think about that doesn't even exist today. So there isn't a standard way to share maps. So we share maps all the time between all these different technology products that are being used in mine, but there is no standard how to share maps and a standing service where you can go and get the latest map. So typically those are imports and exports with files, but essentially we know for open autonomy we need to have a central repository as a service of the map that can be shared between all these services. The FMS component is one of them. Again, this is something that happens today. The miner can go and purchase the FMS they want. And the last component is what I call the earth moving technology. So typically in mining we call them the high precision systems. So those are the high precision systems on excavators, shovel, loaders, dozers, graders. So essentially, this is another important part for open autonomy because we use these pieces of equipment to do all the spotting. So that's how people interact. That's one way that people interact with trucks dynamically. One point I'm going to go back on this, but I just want to say that for today, because AHS and map, because there's safety layers implemented today in the map. So all AHS providers, all the technology has safety layers embedded in the map. So because of that, at least today, whenever there's an AHS solution that is provided, the map, they also provide the map component. So we're going to see that for the several years in the future, but this will change. So I'm sure that once this is a bit more known and we're a bit more familiar with that open autonomy architecture, then there's going to be third parties that will be able just to focus on the mapping system, and AHS is going to be able to take this map, import it, and add the safety function that they need on top of it. So what I've done here is I've reordered a little bit these services and more of in a logical manner. So you have all the iron on the left. So let's start with the truck. So again, your base truck on which you have the specific drive-by-wire kit that you install on this truck. Hopefully in the future this will come from the truck OEM directly. So I guess you'll have the option to buy the truck. You can buy a man cab, or you can buy a computer cab, which is your your drive-by-wire kit. We're going to have a standard interface for the drive-by-wire that can be utilized by the software driver that drives that truck. Now the driver needs to know where to go. We're going to do it the same way we do it with a man fleet today, where there's going to be a dispatching service provided by the fleet management system over ISO 23725, which is the standard that we're working on today. So the fleet management system will have a way to tell the truck will, go to that destination. And it also needs to be able to tell it the routing, so what road segment to take. This is where the mapping service comes in play, where this needs to be a service available on that open autonomy ecosystem. So the fleet management system can read the map, so can the AHS, so they can talk the same language and use the same identification for every road segment. So then when the dispatching is sent to the truck and it says, go through this road and this road and this road, they speak the same language. Then part of that ecosystem, there's the spotting server. So that is once the truck enters the loading area or the dumping area, it's an open area. So there is no road predefined in there. So what they're going to see is there's going to be a high precision, shovel, excavator, loader, something to load the truck is going to be there. And there needs to be a standard means to be able to tell the truck, come and spot here. So that's where we're using, again, the high precision, and that there's a spot server that will be able to share to the autonomy system that's here, well, come to that location. So the spot server will serve spotting location and manage also the queues. So, how big the queues are and where they're located, because, you want to have the queue as far as possible so it doesn't interfere with the loading, but as close as possible so your cycle is the shortest as possible. This spotting service as well will allow the shovel operator, excavator operator to know when the truck is there and ready to be loaded, and it will allow it to, kick out the truck. So then, once the truck is loaded by the operator, it's just, we're instrumenting the horn, so they just, kick out the autonomous truck the same way that it will kick out a manned truck with, just pressing the horn and the truck is on its way. It gets a new messages again from the dispatching system, and the truck will drive to the dump. So at the dump, same thing, the way for miners to interact with the dump and the trucks at the dump is going to be through a dozer, essentially. So you're going to have a dozer that's there with a high precision system using its blade, so the left side of the blade or the right part of the blade to actually, clean the pit, clean the dump, and maintain which bays can be dumped, which one are closed, which one are open, and where they are at the dump. So essentially, that's how the open autonomy services are laid out and how they interact together. So it's not just one layer, as they all work together. Another advantage of open autonomy is, again, what I call, well, the non-native autonomy systems. So because there are open known interfaces, that means that there are other services that can plug in and start collecting data and provide more services or more things that we don't do today, provide new services. So that's one advantage. The other advantage, again, being in 2020, we are defining this standard, so it's using very cloud-friendly technology. So 23.7.25 is, there's a very small binding to specific technology. So we're talking web sockets, and we're talking, JSON objects that are being exchanged, and that's it. So there's no specific cloud or no specific bus or no specific technology where, it's very, very light, and that is enough really to allow us to build this system. So let's go into the different components. And what is an open autonomy enabled FMS? So like I said initially, it's a fleet management system that will provide a dispatching service to open autonomy. It definitely requires the map service, so it needs to be able to connect to the map service, so it knows, where are the lanes, what are the lanes, what are they called. So then when it talks, it converses with the AHS, they can, talk the same language, and that the FMS can show to the dispatcher what's, what the current state of the mine is. It would also, consume the spot in the path So I'm going to go over those a bit later, but again, really rapidly, the spotting location is these here. So if you don't have the spot service, then you're not going to be able to see all these spots. So where trucks are loading and where they're dumping. The path service is one provided by the truck, the autonomy system, and it's all the paths in the dynamic area. So the big open areas that don't have pre-planned lanes, we want to be able to show that and show that to other systems. So the dispatcher, and the fleet management system, or the high precision systems on the earth movers, essentially on the earth moving systems. So the fleet management system will also allow you to do segregation between the autonomous fleet and the manned fleet if you want to, and in certain area allow for mixed operation. A good use case is, the crusher, for example. You probably want to have a crusher where autonomous trucks go and dump, and also manned truck go and dump in there. So you might have some resources, some mining resources that are shared. And as you grow your autonomy, your autonomous fleet in your mine, you can actually start to expand, the autonomous area and shrink your manned area. So essentially, that's what an open autonomy FMS is.
Martin, before you go on, we actually have had a question from the floor. From Elliot Duff. He was just asking, what are the plans for using sensors on the truck or the excavator to create the live map? Is this included in the ISO standard?
No, absolutely not. So again, the ISO standard only defines interfaces, how to exchange messages, and we've put a lot, but I mean a lot of effort to make sure that the data in the messages are not specific to a particular technology. Because if you do that, then you're restricting autonomy to a particular set of technology. We don't want that. Okay, so there is, so we don't say how you do obstacle detection, how do you do obstacle classification, how do you, do you need to use GPS? It's, there's nothing that is GPS specific in these interfaces. There's it doesn't say anything about LiDARs or radars or cameras. So definitely not. And we, it really is at the mining level, so we're abstracting the technology as much as possible and representing everything in more a mining manner. So does that answer the question?
I think so. Elliot, if you have any other comments, please feel free to jump on the question and answer box. Thank you. So I'll let you continue.
Okay, so as far as the earth moving, so the spotting service, so what does that entail? So it entails essentially, the high precision system that you probably know today in mining. So, the ones that you have on your excavators or on your face shovels. And what it does is it's, probably going to be a similar technology that's there. But what it does is it exposes this spotting service. So the spotting service will manage the queue, the queue in that area, in that loading area. It will also manage, the spot. So, which truck can go to what spot, which spotting is available, which one is open, which one is closed, which one does, the shovel operator want a truck to spot under. It also, again, allows the truck to tell when it's ready to be loaded. It allows the operator to kick out the truck when it's done loading the truck. So it exposes all these communication that really happens in a manned environment, but it's exposing it in a digital version, to allow to do what we're doing today, but doing with computers. So we have that type of system on the loading units, and we have a very similar system for the dumps, where you have, your dozers is typically it's going to be a dozer that's going to be there at the dump. So that's an over the edge dump. If we're talking paddock dumping, this is more, paddock dumping is more something that is planned. Okay, so then you would load the paddock plan into the spot server. So that's going to be more of a file that you put and then the spotting service will track as trucks are dumping at the paddock which one are full essentially, and manage the sequence. So the spot service is going to be the one that manages the sequence, so we don't end up quartering ourselves in a place where we can't finish the paddock dumping in a certain area because there are dumps there that does not allow the truck to reach. On the over the edge dumping, again, you're going to have a dozer that's going to be there using its blade as a mouse, as a digitizer, really to advance the edge. So that, obviously as you clean, you're going to clean your dump, but you're going to use your blade as well to define new spotting location on the edge of your dump. And that's one component that can be provided by a different vendor. Again, what it would represent in the FMS is all these colored bays here that shows where they are, but also what state they're in, which one are open, which one are closed, which one's the next one to be used, essentially. So that gives a much richer interface to the dispatcher to understand what's going on in the mine, and when there's an exception, what could cause that exception and what to do. The next component is AHS, the robo driver, the software driver, essentially. So on top of driving, of course, that's one thing it does. It would provide a path service to that open autonomy ecosystem. What's a path service? A path service is, well, when the truck, so this can be either computed beforehand, because when where to spot, then at that point when that spot is created, you can actually pre-compute what path you're going to take. You can either do that, or when you get into the open area, then you're going to have to compute your path. And what you can do is you can actually share that through that path service with all the other components in that open autonomy. So again, especially for the earth mover, so for the high precision systems, the shovels and the dozers, you really want to know where the truck is going to go. And again, specifically for the dozer, make sure that you don't go into that area and not start to interfere where the truck intends on going in the next few seconds. So that's one part. Like I said today, the provider of AHS today is always the provider of the map, and there's nothing in the in the open autonomy that that it's not a requirement, but because of the the technology that is being used today, it's going to be the same provider of AHS is going to provide the map, because again the way that you do the map and the way that AHS interacts with the map, there are today safety layers built in from the AHS into the map, and people want, providers of AHS want to retain that, and they would not feel comfortable if it would be somebody else that is the custodian of the map. So the next component, the map. So essentially, we looked out there, and like I said, it's kind of strange that does not exist already today in mining, but I can tell you it doesn't. So instead of reinventing a new way to share map, we've looked out there, and there's OpenStreetMap that already exists. So it's more than a decade old. If you look at it, it's similar to Google Map. The difference is that it's an open map, and so it's it's not a corporation that owns it. It's actually people that map out and digitize the world and put it in there, and it's pretty much as complete as Google Map is. But the difference is the format of the map and how to exchange them and all that. Everything is open and is available for people to interact and use. So what we've done for Open Autonomy is leverage all of that, all of these tools, all the net knowledge, all of that design that went into the mapping system, and we've added minimal properties in a few of these mapping objects to suit autonomy. Did I see a question?
I think it was just a follow-up from Elliot, just asking, really, I guess, whether or not the sensors on some of the assets, so the trucks or the excavators, can actually provide situational awareness that actually can be dynamically updated into this, maybe even into this OpenStreetMap format. Is that something that you envisage is going to be happening?
Well, they definitely can, and then they somewhat do. So essentially, as the shovel and excavator is operating, it will feed the AHS as far as, well, I've dug in this area, so then this area essentially is updated, so we can grow the face dynamically. And the same thing for the dozer, as the dozer is going and pushing and cleaning over at the edge. This can be sensed and shared with AHS. Well, it would be with the mapping service, which right now is AHS essentially, and update that dynamically. So in essence, yes, it does, but it does not specify the way that it's sensed. So it doesn't, does the dozer use a camera system to really digitize the edge? Does it use GPS and using, the corner of the blade? Does it use a LiDAR and it scans it? Is it maybe a light plan that's there and that, scans the face all the time? So essentially, Open-Autonomy does not specify how it's done, so the sensor set, but it specifies how the information is exchanged. And like I said, the reason, and we try really diligently to do that and not box in Open-Autonomy in a particular technology. Okay, so hopefully that answers the question.
Great.
Okay, so then what does Open-Autonomy also allow us to do? So essentially what it does is it does allow you to keep your current infrastructure that you have. So let's say your current FMS, that is ISO 23725, and then implement your autonomy system. And then it allows you to tomorrow, if you feel that there's a new fleet management system that would provide you, deliver you more functionality, you can extract more, then you can actually replace it without having any ill effect or downstream effect on your autonomy system and your trucks and all that. So that's one problem with the current today's closed technology stack is, if you'd want to do that, you need to to change your trucks. That doesn't make a tremendous amount of sense. It's very difficult. Another thing that it does is it allows you to build that foundation. So you can start manual and buy components that are Open-Autonomy compatible for your fleet management system, your earth moving component of the vendor of your choosing. Buy a truck that has a drive-by-wire, hopefully from the OEM. Start operate in a manual mode, in a man mode, and then later buy the drive-by-wire and buy a different AHS solution that you have not boxed yourself today. By picking a fleet management system, you have not boxed yourself today for the future for a particular AHS system. So it allows you to defer decisions in the future as far as what technology you're going to go and pick. So again, some of the other benefits, incremental change. You can keep the technology components that you have invested in, and again, it's less change management as you change these components. You don't need to change the entire stack. Another big component is the ability to upgrade your AHS and your FMS independently, because if they're highly integrated, and let's say you just want a new feature in the fleet management system, but you need to upgrade the entire stack, so the entire system, because the mine operator is responsible for the safety, you need to redo and do some sort of level of certification that your AHS is still safe to operate in your mine. If those are essentially completely separated and there's no safety involved in your fleet management system, then you can update your fleet management system much more rapidly than you do on your AHS, and benefit from the newer versions without having to upgrade your AHS and retest for safety your entire system. Open-Autonomy also supports mixed autonomous fleet. So again, with a single fleet management system, you can tie 2 or 3 autonomy system to one FMS. So that is possible. That's something that's not possible with the closed stack. So you'd almost need to have 2 different pits if you want to use 2 different systems, 2 different truck types. At your mine, you'd almost have to have them not interact, or otherwise you're going to have 2 fleet management systems that are going to be competing. And essentially, less project costs because you can keep the components that you have, which means you don't need to buy new ones, you don't need to reintegrate them, you don't need to train all your people, on these new systems. You can keep them and change them one component at a time, as as it makes sense, instead of the change management is a lot less. Okay, so now the reality. So that's all nice. Is it just pie in the sky dream type of thing that will never happen? Actually, no. This is something that we're starting to implement now. So unfortunately, even if the standards are not published, and that's a bit of the problem with the process of ISO. It takes a very long time to do that, but actually we are starting to do open autonomy today, and there's really concrete examples of that. So actually the most concrete one is probably one that you've heard about. So Roy Hill is really the first big miner that wants to create a production fleet using this open autonomy concept, where they're not buying a complete closed stack, they're buying different components from different vendors. Essentially, Wenco has been the fleet management system there for 10 years, and so with that, because of that, they get to keep their fleet management system, and they can just plug in the autonomy system. So essentially, on that particular project, which started last year, ASI is providing the AHS functionality, the mapping functionality, and the earth moving, or the spotting service. Wenco provides the fleet management system component. There's going to be a mixed type of truck, so there's going to be Caterpillar trucks, Hitachi trucks there. And there's another provider for the drive-by-wire for these particular trucks that will, plug into this AHS. So essentially, ASI has been in mining, as you probably know. It's a 20-year-old company with about 200 employees. And again, the point I want to make about this project, this is not a POC. This is not a project. This is not a thing that they're trying out, that Roy Hill is trying out. At the end of this project, which is coming there will be more than 75 autonomous haul trucks that will be interacting. So this is not just a test and see how it goes. It's really a full project delivery. The next one that again is been public, so you might have heard about this one, but maybe a bit less. There's another one going on with Rio Tinto, where Rio Tinto, Wenco, and Scania, what we're doing is we're trying out a new type of open autonomy. Instead of doing it with large haul trucks, we're doing it with a swarm of very lower profile trucks, so 80-ton trucks. In that particular project, and this one is more of a proof of concept, so we're talking about 6 trucks, so we're not talking about 70 or 80 trucks, but it's still a significant fleet. Scania is providing the truck, they're providing the drive-by-wire system, the autonomy, and the mapping system, and Wenco will be providing the spotting service and the fleet management service. and this is a project all run by Rio Tinto. So Scania is a very old and huge company. The interesting part about Scania is that they will deliver autonomy on the cloud. So the other ones, we've talked about it, but it's still on-premise type of autonomy. But because Scania also want to be able to deploy that on the public road infrastructure, their autonomy for mining is going to be on the cloud. And this is how we are currently integrating and testing it. Is their servers are not on premise. They're not at the mine site. They're actually in the cloud. So that's happening, and that's again using the draft version of 23.725. Scania, Rio Tinto are part of members of that ISO standard. The third one that's happening is Safe AI. So this is a smaller company, so they're 3 years old, and they're mostly operating in quarries. And we are doing cloud type of integration with Safe AI. Safe AI is developing their mining opportunity. There is no contract today, but essentially in that case, Wenco would be providing the fleet management system, the spotting service, and Safe AI would do the mapping in the autonomous driving. They don't have truck, obviously they don't build trucks, and they don't build the drive-by-wire. The drive-by-wire would be supplied by a third party in that context. So I've kept the most exciting one for last, so kept the best for last, and that's one with Oxbotica that we're working on. And there's two reasons why it's so exciting. The first one is that particular one would have never existed without Open-Autonomy. So I think we could argue that the other three that I talked about, they've already been involved with mining, and maybe it would not have been a standard interface, but those projects probably would have happened on their own. But this project, the one with Oxbotica, the only reason why we can use them is because there is an Open-Autonomy, and I'm going to go a bit further on that. So essentially, Oxbotica is a 6-year-old company. They have about 150 employees, and it's a spin-off from the Oxford University labs in the UK, where they do a lot of vision and machine learning, using all the latest technology. So actually, that is the second really exciting part about Oxbotica, is that they're using like the latest and greatest technology that we can actually move into mining. And because if you look at what's out there today, they're all using essentially the same technology. So the autonomy systems today are using GPS. So without GPS, the trucks are not going to be able to drive. They're highly reliant on radio communication. So then if there's a blind spot in the mine, probably HS is not going to run in that area. So it's similar technology. But with Oxbotica, they actually have cars running on the public road today in the UK, well, in Oxford, and in Germany. So that's a completely chaotic environment, and I've rode in one of those cars, so it's not, it's true, it's real. So Open-Autonomy allowed this technology really to be able to leverage it into mining, which before Open-Autonomy they could not, because essentially Oxbotica, they don't produce trucks. They don't really know anything about trucks. They don't have drive-by-wire. They connect to light vehicles and cars, so road type of cars. What they really know about is how to automate cars, how to create map. So they're using SLAM, so it's a mapping type as you're driving. And that's the part that is really interesting as far as the technology, is that it's a lot more self-contained. So because they're using SLAM, they do their localization in the map using features of the road, features of the environment to know where they are. So they're not based on GPS Can they use GPS? Yes, GPS can be one of the sensors that feed Oxbotica, but actually that's why this technology is so exciting, is that it doesn't rely on it. It doesn't need a constant feed with a server for safety purposes. It's really all contained on the onboard, so it's a much smarter type of self-driving technology. And like I said, what it allows Oxbotica to do is enter the mining market without having a lot of knowledge or building a fleet management system, without building a high precision system. What is an excavator? How do they do it? How do you spot? How do you kick it out? All these things, they don't need to learn about it, because they can actually just use the building blocks that are there. So essentially, we are in talk with a very large North American miner today. There's no contract signed, but it's really progressing. And keep your eyes open for this in the next couple of years. That's going to be very exciting. And that's my last slide. I haven't had a lot of questions, so hopefully there's going to be a lot of questions soon. Essentially, Open-Autonomy really inscribes itself really well into Wenco's vision. So typically the pit has been pretty much optimized as a silo, and we know that miners really want to take control of their supply chain and change it from a push to a pull. And essentially, what's required for that is all this interoperability, well, actually real-time interoperability, and that's where Open-Autonomy is part of that puzzle, really, to deliver this material movement automation system where is where we want to go, where essentially the data flows in real time from your exploration to your planning, to the pit, to the mill, to the transportation, to the port. So essentially, that's it. So that's how Open-Autonomy fits into our vision. And again, we're really into different standards and interoperability, and that's it. So hopefully there are questions.
Thanks so much, Martin. That's really, really actually very fascinating insight into the work that you've been doing in the future direction of autonomy in the mining sector. So thank you. We do have some questions. The first question is from David Seaman, also commenting on great presentation, but he was keen to ask how receptive the major manufacturers are to open autonomy. Do you think they will embrace it or attempt to maintain closed systems? And as a second question, he'd also be interested in your integration with underground systems as well.
Yeah, that's definitely a great question, and I need to put my political hat on it for a second here. So essentially, yes, it's been very difficult for the dominant players. They have tried to slow down this openness, essentially. But I must say, in the last few months, I think, so what happened is miners saw that. So, big miners saw that. So, the Rio Tinto, the BHPs, they've seen that was happening, and because they're also part of these ISO standards. And I think, the ones that control the technology today that are really dominant understand that they can't stop that progress. I think at best, that they can slow it down. They're definitely not, helping to get that done. But at this point, I don't think that they can stop it. But yeah, that's a great question, and that's definitely something that is happening or has happened, and is still something that we need to keep our eyes open for.
And just the second part, in terms of the underground systems, is that something you've been working on as well? So
no, I'm an open pit person. I've worked underground for about 6 months essentially, so I don't know a lot. I know little, so I'd rather say that no, I don't really know for underground. I know too little to really talk about it.
Sure. Okay. No, thanks for answering that question. So another question here we have from Gordon Forbes, also commenting on a great presentation. So Gordon is just asking, do you see any chance of individual components being made open? Because from what he understands, the interface or the API is open, but not the individual components themselves. An example being mapping products are now competing with the closed source Esri products, and those that have invested time and money in their IP don't always necessarily want to just give it away.
I think probably I don't really understand then what he means by the components. So probably, okay, so Esri, so we're talking about the mapping, right?
So maybe it potentially goes back to something that Elliot was also talking about with some of the other sensors. If there's the individual components, are they going to be made open as well?
Okay, so I think from what I understand of the question, which is how can we start breaking those big components, the big chunks that I have, that I've presented, that's not mine, but can we break them into smaller components? And that's going to be an iterative approach. It's just evolution of technology. That's how it works. So once we have a good idea how these big chunks of components of functionality, because I mean these interfaces they don't all exist, and they're not all approved, and we don't have consensus on them. So we're going to start to have these consensus on these big chunks of interfaces before we start having consensus on sensors on trucks. So for example, I think maybe one example would be obstacle detection on trucks. So those are things that we talked about. But the thing is that the obstacle detection is so intertwined in the safety layer on the truck that it's going to be very difficult to have, at least in 2020 or in the next few years, to have a standard interface. How can you purchase a third-party obstacle detection and putting on your truck? Because it's so unknown, it's still changing rapidly, and there's so many different sensors. So again, you can do it with camera vision, you can do it with LiDARs, you can do it with radars, you can do it with a lot of different sensors. So how can you have a single interface? So essentially, these will come, but they will come in the future, I believe, where it's going to be evolution of technology. Once we know a standard interface and we know what that big block does, then we're going to be able to cut it into smaller components. So they will come, but I think in the future.
So, and I guess kind of a follow-on, Elliot said he has to run, but he just made one comment just early on. He said another advantage with open autonomy is that you enable open innovation ecosystem, which increases the scale and speed of innovation. So potentially what you're alluding to there is potentially we can actually open this up and integrate different companies or people that are building different sensors and integrate it into the full system.
And again, definitely, and the big, again, that's the exciting part. One example that is concrete is Oxbotica. Again, they could have never entered mining how they were. So then, yes, this definitely opens up for other players which have different technology, which is going to stimulate technology and a lot more vendors and more innovation into mining. And definitely that's one part that why we want to have this open autonomy, and one part why miners want to have open autonomy. I mean, they know that's what it's going to do. If you have a few players that have maybe older technology and none of them are innovative because they're continuing on that wave, unless there's a disruption that comes in, which open autonomy allows, then they're likely going to, not necessarily slow down their development, but until there's really a real reason to invest more into newer technology being innovative, or you're just going to ride that wave as long as you can, right?
That's true. Probably just one final question from Martin Stringer here at UQ. Does increasing automation necessarily lead to increased electrification? And I suppose this is a curious question in terms of are miners retrofitting their existing fleet, or are they going to move to electrified vehicles, in which case they may modernize their entire automation system as well?
So Again, I'm not an expert in electrification. I know of it, you know, because, you know, I read on the industry and what's going on, and it's a very interesting subject. I think that they are not related. You know, I think that, you know, both, because even on a manned fleet, whether you have a manned fleet or you have an, you know, an autonomous fleet, you know, if you can use electrification, which again is not only better for the environment, but let's say we're talking trolley or newer technologies, typically they're going to be cheaper. So if you can use electricity, your total cost of ownership, you know, to produce 1 ton of ore is going to be cheaper using electricity than, you know, using diesel. That's for sure. So only on that side, but not only on the economic side, but also on your, you know, environmental impact. So I don't think one is driving the other. But, you know, like was mentioned, obviously, if you can, you know, buy electric systems, electric trucks, they're likely more going to be drive by wire. You know, they're not going to be driven by mechanical gears. So, you know, maybe that part, the electrification might help autonomy in that sense.
Okay, great. Well, thank you for answering those questions so fully. I do notice we are a little bit over time, so a couple of questions have just come in. What I might do is direct those to you via the email and ask if you could just reply to the, we've got a question from Tim Skinner and Fernando Vieira.
Oh, Tim is there. Hi, Tim.
Certainly, it would be nice to keep talking, but unfortunately we have got a sort of tight time schedule we have to stick to. So certainly Tim and Fernando, I'll direct those over to Martin and we'll hopefully get those answers back to you. But just for now, Martin, I just wanted to thank you one more time for your excellent presentation. Certainly it's been very insightful. Just for next week, Friday the 25th of September, we have Professor Dave Craw from University of Otago, and he'll be talking about prediction and mitigation of environmental issues at gold mines in southern New Zealand, successes and lessons. So we hope that you can join us then. And just for now, I'd like to say thank you one more time, Martin. Thanks everyone online for joining us, and we'll see you next week.
Thank you.
Thanks very much. Bye.